Cognitive robotics. Endowing robots with mammalian and human-like cognitive capabilities to enable the achievement of complex goals in complex environments. Focused on using animal cognition as a starting point for the development of robotic computational algorithms, as opposed to more traditional artificial intelligence techniques, which may or may not draw upon mammalian and human cognition as a inspiration for algorithm development. What is a cognitive robotics? Cognitive robotics is a new approach to robot programming based on high-level primitives for perception and action. These primitives draw inspiration from ideas in cognitive science. There is a growing need for robots that can interact safely with people in everyday situations. These robots have to be able to anticipate the effects of their own actions as well as the actions and needs of the people around them. The merging of these two areas has brought about the field of cognitive robotics. This is a multidisciplinary science that draws on research in adaptive robotics as well as cognitive science and artificial intelligence, and often exploits models based on biological cognition. A key feature of cognitive robotics is its focus on predictive capabilities to augment immediate sensory motor experience. Being able to view the world from someone else's perspective, a cognitive robot can anticipate that person's intended actions and needs. This applies both during direct interaction, that is a robot assisting a surgeon in a theater, and indirect interaction, for example, robot stacking shelves in a busy supermarket. In cognitive robotics, the robot body is more than just a vehicle for physical manipulation or locomotion. It's a component of cognitive process. Thus, cognitive robotics is a form of embodied cognition which exploits the robot's physical morphology, kinematics and dynamics, as well as environment in which it is operating, to achieve its key characteristics of adaptive anticipatory interaction. Cognitive robotics as building robots with cognitive capabilities, high-level perception and action, attention, memory, learning, concept formation, reasoning and problem solving, communication and use of language, theory of mind, social interaction. Cognitive robotics as applying knowledge from cognitive science to robots. Cognitive psychology has described cognitive capabilities of humans. Cognitive science tries to build computational models that could be implemented in a robot. But why should robots work the way humans work? Maybe robots can do things better than humans. On the other hand, maybe there are good reasons for why humans work the way they do, and we can learn from that for robotics. Cognitive science tries to understand why human cognitive capabilities are as they are. Traditional cognitive architecture, artificial intelligence, perception, cognition, action, that goes to environment. Advantages of cognitive robotics: replicating child psychology experiments, testing psychological theory, and finding common process underlying disparate phenomenon, developing technology, prompting new technology and questions. Cognitive system: information enters the consciousness system as input and reaches the cognition system, used for neural computation together with the information from BL, internal information. derived from the derived information transmitted to oral cognized information. Language labels have different areas for condition of self and others. Behavior system. Behavior information from BL passes to behavior system. Information added to the input and sensory information by neural computation. Resultant information is transmitted to output to implement a behavior. Common areas for the cognition and behavior system: behavior learning during cognition and cognition learning during behavior. Each piece of information is correctly related to language labels of symbolic representation. The consciousness system brings a process of artificial thoughts as information is circulated. Example: human language, conversation between self and others. The input, the speech of both self and other is the input. Somatic sensation that self is talking is fed back as input. Behavior of new language label through circulation gives rise to thinking and expectations. Possible to offer new topics for conversation. Thank you.